Hello and welcome everyone to today's video. In today's video, we are going to learn about how to create a reused library component and how to create a reusable part inside NX. Okay. Now, first of all, we need to understand what is reuse library. Now, basically, reuse library is a set of libraries which is accessible throughout the different environments of NX, which we decide to be accessible with. And along with that, we can also decide what kind of components our company create on a regular basis, and we can add those level of components as a reusable component, so that we don't have to create those components again and again, and we can create those using reuse library. Okay, so I'll be teaching you multiple ways of using reuse library today, and I want you to have NX and at least Microsoft Excel installed in order to this particular option to work. Now, what we are going to do first of all is we are going to create a library location. Now, this can be on a network, okay, or this can be in your PC anywhere you want to. For example, here I want to create a reusable location or reuse library location inside my D drive, and here I'm going to create a new folder called library or LIB. Now, this particular folder will act as a folder in which I'm going to save all my reusable component. Now, let's say here I'm going to create a different level of components. For example, if I give you an example of a mold, so here we can create guide pins. Okay, we can create bushes if I want to. So I can create multiple subfolder structures, okay, based on what kind of components I'm going to create. Okay, so once I have done with that, okay, like once I have created my library folder and library structure, and once everything is organized, you can have nuts, bolts, and different things which you normally use in your assembly, for example, campaigns and other things. So all those things can be created as a separate folder, but not as a part. Part creation process will be done using NX. So once the folders are ready, then what we are going to do is now we are going to use NX part environment in order to create our reusable component. First of all, we need to create a new file. So here I'm clicking on new. I'm selecting model, and the location in which I want to save my file should be the same as the library location. So first of all, the process is creating library components. So let's say here I want to save my file inside the library folder itself, not inside a subfolder of bush or guide pin, just inside the library folder itself. And here I'm going to name it direct. Now, what is the meaning of direct means this particular part will have a fixed size and fixed set of parameters which will be directly imported into an assembly without any changes. So for example, here what I'm doing is I'm adding a simple cylindrical geometry. Okay, so I'm creating a sketch on my top plane. I'll just finish my sketch again. I'll restart my sketch. So here I'm creating my sketch on my top plane. Then here I'm creating a circle at the origin, let's have diameter 200. So here I'm entering the value of diameter as 200. I'll click on finish. Here I'll click on extrude, and then I'll define this particular extrude with a height of, let's say, 250. So once I'm done with this, I'll click OK, and this is how my entire model is going to look like. Now once I'm done with this, I'm going to save the file. Okay, and this is going to be my direct part. Now, depending upon the kind of model you are creating, it might take a while to create for the library. Okay, or otherwise you can create a direct model like the way I have just done. Now, once I'm done with the direct modeling approach, I'm going to keep this file open because I just need to, get it access, or I can just simply close this particular file. And now I can start with a new file. What I'll name this as KRX. Okay, now this is a different type of file which will have reusable sizes, locations, and other things. Okay, for example, here I'm creating a file called KRX, and here I'm going to create one particular object. Okay, now let's say, for example, I want to create a spring. Okay, we all know how spring works, right? So let's say, for example, I want to create a spring, and in this case I want to create a spring of different diameters technically, or let's say of different length particularly. Okay, so I want a compressed state, a non-compressed state, and different other components, okay, of the spring. So normally for the creation of spring we need certain parameters like pitch. Okay, that is the distance between the revolution, the revolution number of turns we can say in particular. Okay, how many number of turns you have, and the height. And if you're good with the concept of springs, it is very easy to calculate any one data if you have other two datas. For example, the pitch of the spring, okay, is normally calculated as the number of turns divided by the height, and you get the pitch of the spring. Okay, or you can say in proper terms, the height is actually divided by the number of turns. So you get the proper height. Similarly, if you want to calculate the number of turns, okay, you just need to simply divide the height with the value of pitch, and you will be able to create or you will be able to identify the number of turns. Similarly, if you want to identify the height, then you just need to multiply the number of turns, okay, with the pitch. So you just need to multiply turns with the pitch and you will get the height. Now here in NX, what we technically do is we never create a helix with a proper height. We generally define height is as a parameter, yeah, but we normally consider turn and pitch, because normally in most of the cases we don't keep the height constant. But what we are going to do right now is we are going to keep the height constant, and I want my number of revolutions to change with respect to the kind of height I am having. Technically the number of revolutions should not change, but the pitch should change. I also want the number of turns to be fixed. So what I'm going to do first of all is, for creating this component, we are going to go to tools, we are going to click on expressions, and expression will be a good mate over here because you will be able to create multiple things using expression itself. So for example, here the two constant factor which I'm going to use in my design is going to be the height and the number of turns. So number of turn is going to be a constant factor, okay, which will not be changed. Height is a factor which will be changed, but which will result in the change of pitch. Okay, for example, here what I'm going to create a spring is with a height of 200 with 10 turns. Okay, for now it's a very simple example. So my pitch in this condition should be height, okay, what I have just created, divided by turns. Okay, so my pitch should be equal to height divided by turns. If I click on apply, so this is a value for my pitch which is automatically generated. This is not something which I have generated manually. So you should be good with expression if you want a reusable component. Okay, so that is the key over here. Now I'll go to the curve tab, and here I'll click on helix. And what I'll do here is, I know certain parameters. The diameter is going to be constant for now. For now, I'm not going to change the diameter of helix. If you want, later on, you can keep it changeable as well. For example, as of now, I want to keep the diameter of my helix as 40. So I'll just change the diameter to 40. The pitch value will be equal to pitch value, what we have defined there. Okay, so whatever the pitch value is, it will automatically take that in consideration. And the end limit will be equal to the height. Okay, so the pitch is equal to the pitch value. I'll just zoom in so that every one of you can see. The pitch value is equal to the pitch, and the height length value is equal to the height. Now once we have defined all the parameters correctly, I'll click OK, and now my spring is ready. So normally what will happen now, if I go to user expression on the left, and if I change my height to 100, you can see the spring getting compressed as the number of turns is going to be constant. Similarly, if I increase my spring height to, let's say, 200, again the spring will get decompressed. Okay, for a major decompression, I can also take a spring value to 500. So again, it's getting even decompressed by a higher value. Okay, so let's say, for example, here I am creating a spring with an initial height of 200 and which the initial number of turns set to 10. Now once I'm defined with that, I can simply go to the surface tab and choose the option called tube to create a 3D geometry. So once I select this, I just need to give the diameter. Let's say I'm working with 5 as of now. Okay, and I've created a proper video on how to use tube properly. So if you want, you can also look at that. And along with that, I have also created different videos on different sweep command. If you want, you can have a look at that as well. So here, as you can notice, a spring is created. Okay, a proper spring is created. And now I want to add this also as my file for the library. So first of all, what I'm going to do is I'm going to press save, and I'm going to save this in the same location where my other part is saved. For example, if I just take you to that location, so if I just take you to the library location, inside the library location, you can see there are two files, direct and Krx. So this is all saved in the library location. If it is not, you can even move it over here. Once you have done with that, then our library part creation process is completed. Means the first step of creating the library is already done. Now let's move to step 2. How to make it in the library. How to bring it here. So here, as we can notice over here in the left, we have this particular icon that is used for reuse library, and there are a lot of them. Okay, so if you are especially having a mold wizard license, you will have a lot of libraries which are already pre-installed. Okay, now what I want to do is I want to add my own library location. So here I have this particular button called library management, or you can even right click in the blank area of the library and choose library management. Now once you go to library management, this is something which is going to pop up. This will show you the exact location of all the components which is placed inside the library. So even you can go to that location and see how exactly the components are laid out. Okay, if you so wish to. or else you can even click on this particular button called add library. Now once I click on add library, it will ask me to which folder I want to create a library. Now by default my file is getting saved in the library folder, so here I am into the library folder. I'll click OK, and this particular folder like dlib will be the library folder. Now if you want, you can give it a name. For example, here I'm giving a name of CAD CAM Galaxy as the name of my library folder. Now once I've defined the name, I'll click OK, and now my library folder should be added. Okay, now once my library folder is added, okay, next thing what I need to do is I need to make some automation to my folder. So here what I'm going to do is, here I'm going to click on member select. Okay, and here we have a KRX model. So one is the direct model. Direct model has nothing to do with what we're going to do in the next step. Now if you want, you can right click, and here you can create a KRX file for this particular model. So I'll click on generating a KRX file. Okay, but here we don't have any parameters which are preloaded. So what I'm going to do first of all is, before I create a KRX file, in this particular model, I'm going to create multiple sizes. And to do so, I'm going to click on tools. Okay, and here I'm going to click on one particular option called part families. As we can notice over here, there is an option here called part families. So once I click on part families, and if you are using a newer version of NX like me, you will get a similar dialog box. If you are using an older version, you will not get the right side portion over here. Okay, so if you are using a newer version, continue with me. And if you are using the older version, you have to continue from here. Okay, so here, first of all, there is part name and part number. Along with that, I want height, turns to be the part of my reusable component. So here I'll just click on add. And this is easier now because I have created an expression called height and turns. Okay, now once everything has been defined, you can also reorder the columns if you want to, or if you so wish to. Once everything is properly arranged, what you just need to click on is this particular option called create spreadsheet. And once you click on this option called create spreadsheet, it will automatically open MS Excel for you. Now remember, in this particular case, we are not opening Excel by ourselves, and this information is not initially entered by us. Okay, for example, here I'll just enter the part name as Spring 1. Okay, and likewise I want to create few instances, let's say up till Spring 10. Similarly, I want to create a part name of this particular component as, let's say, Spring. Now part name is something which can be similar, okay, but it will be easier for us to identify later on in the future if you have different name. Now here I'm just entering Spring 1 as a part name and adding, let's say, 10 instances of that. Okay, now here I want to define the height. Now let's say in most of the condition, my height is going to be a different value. For example, the height can be increased by 100 ever so slightly, or it can be a totally different value. Okay, for example, 100 here. So there are different conditions of height. Okay, now in some condition, I also want to keep my height constant and vary my turns, number of revolutions. So here in all the cases, the number of revolution is same. But let's say in some cases, I want to keep my number of revolution to be different. For example, here I want 15, here I want 5, I want 10 over here again. Or let's say here I want to keep 20 revolutions. Okay, make sure it doesn't self-intersect, okay, based on the parameters you have used. Okay, here I'll use 8 and here I'll use 9 revolutions. So here I have all different revolutions over here in the same limited height. Now once I'm done with that, once I'm defined all the parameters, okay, and once I'm happy with the data what I have created, I need to go to the add-ins tab inside Excel. I cannot close Excel manually. Okay, I have to go to the add-ins tab. In part families, I have to click on this option called save families. Now as soon as I save the family, the data will be loaded here on the right side. Okay, and it will automatically be updated. Now if you are using a newer version like me, you will be able to change the data later on from here. But if you're not using a later version, you will be, all you are having is this particular set of option. Now once you're done with that, in either ways, I can click OK, and now part family has been changed. I just need to save the member. I'll click OK and I'll save the file. So once my file is saved and once my part family is updated, now I can right click on the KRX model and choose to create a KRX file like the way I had done previously. So for accessing this, you have to be inside the member select area of your library folder. So here I'm going to right click and choose to create a KRX file. Now you can see there are some parameters over here which are there. Okay, so I want to control my KRX file based on the height and the turns, and here I'll just add it. Now as we can notice, the spreadsheet data is already blank because the spreadsheet is already present, okay, in that particular location, and this is a file, this is a name. I just want to control the height and the number of turns, and I'll click OK. So there are two files which I have created. One is a direct file and one is a KRX file. Now how to use this set of files in an assembly? Okay, it's very simple. I just need to create a new part or a new assembly. Okay, and there you can use this particular file. So I'll just change the location for now. I don't want to create anything in the library location. I'll just change to a random location. By the way, I have already created a video on creating a benchwise assembly. So if you're interested in that, you can also have a look at that particular video. There are some part of the videos which are still in progress, which is already been uploaded, but it will come out later in the day. So you can also have a look at that. Now, once I click OK over here, now the software is like a blank file for me again. And if I want to add anything, okay, let's say considering this as an assembly, I can just simply go here on the left, choose my library. If I want to add this particular component into my assembly, I can just simply choose right click and add to assembly, or you can even double click. Now here it will directly browse or help you to identify the set of constraints you want. But if you don't want to give any constraints, you're good to go. Similarly, what will happen if I add a Krx file to an assembly? If I add a Krx file to an assembly, it will ask me the height and the number of turns. Now, based on the parameters, for example, the height of 200 has multiple values for turns, so it is asking me both. Okay, but the height of 500, for example, doesn't have multiple values of turns. So let's say for height of 200, I want 25 turns. So I can or 20 turns, which I have defined later on. So I can just simply create one of that and I can click OK. Now it is not visible only because there are two components overlapping each other. So I'll just hide it and you can see over here. Now what I can also do is I can right click and I can edit my reusable component anytime I want to. I can anytime change the number of turns and you can see a different component is automatically updated, like Spring 9. If I choose to edit reusable component again, let's say I want to go with a size of 100 and I'll click OK and you can see a different component is automatically loaded. So this is how you can create a component using a reuse library. You can create one of the direct component which doesn't have any changeable parameters, or you can create a component with Krx file which is having a changeable set of parameters. Thank you very much for watching. Have a great day.